Okay, so we have discussed the concept of kinetic energy. Now let's solve some numerical questions based on the concept. Numerical questions will going to help you to understand that concept better. So let's start with practice question number 7. The question 7 says, how fast should a man of mass 60 kg runs so that his kinetic energy is 750 joules? Okay, so question says that there is a man who will going to run with some speed. Okay, his mass is 60 kg and he need to achieve the kinetic energy of 750 joules. Now it's not like that this kinetic energy will going to be created. It will come from some other energy. For example, he is running, so the food that he has taken, that food will be converted to energy, and when he runs, the same energy that he acquired from the food will get converted to kinetic energy. So it's not like, don't think in this way that kinetic energy is he produced the kinetic energy or he created the kinetic energy. It's because the energy cannot be created. You cannot create energy, you can just transform it from one form to another form. Okay, so let's see the question number 7. In the question number 7, the mass of the person is given as 60 kgs and the kinetic energy that he wants to achieve is 750 joules. Now how can I calculate the velocity or the speed with which this person has to run? We know a very important concept, that kinetic energy is half mass into square of velocity. Okay, now using this formula, that mass into half into square of velocity, I will say that from this I can write velocity square is equals to 2 times of kinetic energy upon mass. That is, it implies velocity is equals to square root of 2 times of kinetic energy upon mass. So it means I have to take the square root of 2 times of kinetic energy into mass. So here what we will do, we will substitute the values, that is square root of 2 into, now kinetic energy is 750 and divided by 60. Now you have to cancel here, this 0 will get cancelled with 0, 2 1s are 2 and 2 3s are 6, 3 1s are 3 and 3 this 25 times 75, so velocity will come out to be 5 or square root of 25, that is it will be 5 meters per second. Okay, so this is the velocity with which the person has to run 5 meters per second of a mass of 60 kg person. Okay, it's not like that if a person run with the velocity of 5 meters per second, he will gain the kinetic energy of 750. His mass has to be 60 kg. If his mass is different, the kinetic energy will obviously going to change. So here we have calculated with that, with this speed, if the person runs, if he has a mass of 60 kg, his kinetic energy would be 750 joules. Okay, so this completes question number 7. Let's see the question number 8. Find the mass of a body which has 5 joules of kinetic energy. So in this question, kinetic energy is given as, question number 8, 5 joules. Okay, while moving at a speed of 2 meters per second. So the speed of the person is 2 meters per second and our task is to calculate the mass of the person. Okay, so the complete question is, find the mass of the body which has 5 joules of kinetic energy while moving at a speed of 2 meters per second. So definitely speed is given, its kinetic energy is given, and we have to determine the mass of the person. So again we will going to use the same concept, that kinetic energy is equals to half into mass and square of velocity, that is half mv square. Now from here you can see, to calculate the mass, I will shift this 2 in the LHS and this v square again in LHS. So 2 times of kinetic energy upon v square will be the formula for calculation of mass. So here I can substitute 2 into Now kinetic energy is given as 5 upon v square, that is square of velocity. So 2 square, so this will give you 2 into 5 upon 2 to the 4. Okay. So this is 4. Now you can calculate from here 2 and this is 2. So 5 by 2 means 2.5 kgs. So this comes out to be the mass of the person. So if it's like a baby, okay, it's a small baby. If a baby of 2.5 kg weight, if he runs with the speed of 2 meters per second, or if he walks with the speed of 2 meters per second, then his kinetic energy would be 5 joules. Okay. So try to realize the kinetic energy. So similarly we completed question number 8. Now let's move to the 9th one. A player kicks a ball of mass 250 grams, okay, at that is 2.5 kgs at the center of a field. The ball leaves his foot with a speed of 10 meters per second. Now find the work done by the player on the ball. So it says that a person, 250 grams of ball, 250 grams of ball. So there is a person, there is a player who kicks a football of 250 grams, okay, and the ball acquired a speed of 10 meters per second. Now initially the ball was at rest, the ball was kept on the ground, and if the player comes and kicks the ball, what will happen? It's like the foot of the player and the ball will going to collide with each other, and the player will transfer its energy to the ball. Okay, what the player will do, he will transfer his own energy, the energy that he has inside his body, he will transfer that energy to the football, okay, and the ball will start moving. And it means that ball has acquired energy. Now from where does this energy come from? This energy comes from the player itself, okay. Now what exactly the player did to transfer its energy? Player did some work, okay. So work done by the player will get transformed into kinetic energy and it will be transferred to the football. So here we will write this statement as well. Question number 9. The work done by player will get transformed into kinetic energy of ball. Okay. So the work done by player will be equals to work done by player will be equals to kinetic energy of ball. Now if we talk about ball, what is the kinetic energy of ball? The kinetic energy can be represented as half mass into velocity square. Now what is the mass of the football? Mass of the football is 250 grams. Now can I use it directly 250 grams? No, it's because it has a unit of grams, but in our formula we use the unit of mass as kilograms, that is kg, which is the SI unit of mass. So we have to use the SI unit, so it means I have to convert this unit of this 250 grams into kgs, okay. So 250 grams is equivalent to 0.250 kgs. It's because 1 kg is equals to 1000 grams. So this is the mass, and the velocity of the ball is given as 10 meters per second. So the ball has a velocity where I can write velocity. Velocity, let me write here. Velocity is 10 meters per second, it is given. So the work done by the player will be half into 0.25 into square of 10. Okay. So this will give you half into 0.25 into 100. Okay, into 100. It's because square of 10 is 100. So 0.25 into 100 is 25. 25 upon 2 is half of 25, that is 12.5 joules. okay, that is 12.5 joules. So this is the work done by the player to give a speed of 10 meters per second to a 250 grams ball, okay. So this is the solution for question number 9. Let's see question number 10. A body of mass 5 kg initially at rest is subjected to a force of 20 newtons. What is the kinetic energy acquired by the body at the end of 10 seconds? Okay, so it says that there is a body which is 5 kg of mass and it is subjected to a force of 20 newtons. Okay, now it's given that the force is 20 newtons. It means you can consider that force is a constant force, that is 20 newtons. If it is not mentioned that what kind of force it is, you can by default assume that the force is constant force. So this is a constant force of 20 newtons. It is applied to a body of 5 kgs. So let's try to draw the diagram for this. This is a floor and this is a mass of, let's say, 5 kgs. This is 5 kg mass, and I applied a force F on this body which is 20 newtons. So this 20 newtons force is applied on this body, and it's not like that it's applied for once. It is applied continuously. Okay, it's like I'm holding this block and I'm continuously pushing it like this. So it means the force is constantly applied on this 5 kg block. So it is asking that after 10 seconds how much would be its kinetic energy. So to calculate the kinetic energy, what we need from this formula, you can see half is a constant, mass of the body that is given, that is 5 kg, and the most important, velocity, that with which velocity this block is or this body is traveling, that is also very important. Okay, so first we have to calculate the velocity of the body. So how will we calculate? We will apply some concepts of Newton's laws of motion and also the equations of motion that you studied in the previous topics. So here I can see that force is basically mass into acceleration. From this I can say acceleration is equals to force upon mass. So acceleration will be equals to force, that is 20 newtons, upon mass, that is 5 kg. So this will give you 4 meters per second square. Okay, so I can see force is 20 newtons and this mass is 5 kg, so 20 by 5, that is 4 meters per second square. This is acceleration. Now using the acceleration I can calculate the velocity. How? By using the first equation of motion. By using the first equation of motion. Now according to first equation, V is equals to U plus AT. Okay, V is equals to U plus AT. V is the final velocity, U is the initial velocity, A means the acceleration and T means the time. It is given that I have to calculate the kinetic energy after 10 seconds. So it means this T time would be equals to 10 seconds. What is acceleration? It is 4 meters. It is given. What is initial velocity? You can read the question. It says a body of mass 5 kg initially at rest. Initially at rest. It means initially the body was not moving. That is, the speed or the velocity of the body initially was 0. So it means the initial velocity is given as 0 meters per second. So here I can write V is equals to U means 0 plus A, that is 4, into T is 10. So velocity will become 40 meters per second. So 40 meters per second is the velocity of this body. So can I calculate the kinetic energy? Yes, I have mass, I have velocity. Now I can very easily calculate. Kinetic energy would be equals to half into mass into square of velocity. That is half into mass is 5 kg into square of 40. Now this is squared. So you can calculate half into 5 into 40 into 40. Okay. So this is 20 times. Now this will give you 5 2s are 10 and 100 and then 4. So it is 4 and this 2 0 and one more 0. So it is 1000 joules. Okay, so kinetic energy will come out to be 4000 joules. Now you also know that 1 kilojoules equals to 1000 joules. So I can write this same kinetic energy in the form of kilojoules, that is 4 kilojoules. Okay, so the kinetic energy of the body comes out to be 4000 joules or 4 kilojoules. Okay, so this completes question number 10. So these are some very interesting questions based on the concept of kinetic energy. Now you can note this and then we will continue with the potential energy. Okay. Okay, so we solved some numerical questions for the concept of kinetic energy. Now let's discuss with a different form of energy, which is it's like very important kind of energy. Okay, you daily used to see this or realize this, but you never felt that what is the name of this kind of energy. Okay, so as I said that any body which is doing some work, okay, which has the ability to do work possesses energy. Okay, we discussed that the object or the body which is in motion has an energy which is known as kinetic energy. Okay, that is by virtue of its motion. Okay, due to the motion of the body it possesses kinetic energy. But is it like that the body which do not possess motion do not have any energy? No, it's not like that. The body which is not moving, which is stationary, which is at rest can also possess energy, but that energy we cannot call it as kinetic energy. We will call it with a different name, and the name is potential energy. Okay, we call it as potential energy. It is different from kinetic energy, it's just totally different from kinetic energy. Kinetic energy is due to the motion of the body, that is, if a body is moving it will possess kinetic energy. But the body which is not moving, okay, if the body is not moving we will say that it can possess potential energy. Now as I said that, for example, let's say this is a chalk. Okay, if I throw this chalk, what will happen? It will start moving with some particular velocity. Okay, and if it is moving with some velocity, definitely it will possess kinetic energy because it has some mass, it has a finite mass. Okay, let's say 5 gram, 2 gram, 3 gram, and it will, if I throw it, it will going to have velocity, so it will going to possess kinetic energy. Now to throw this chalk, what I have to do? I have to apply my energy, and by applying my energy I did some work to throw this chalk. Okay, this is a work, I have done this work because I applied the force, I displaced it from its position and I throw it like this. So what I am doing? I am applying force, I am displacing it from its original position, I am creating some finite displacement. It means I am doing some work, and that work is stored in this chalk in the form of kinetic energy. Okay, in the form of kinetic energy. But it may happen that if I do work on this chalk, it will not move. May be possible that I did some work on this chalk and it is not moving. Okay, for example, let's say this is a chalk. Okay, I am holding it like this and I moved it from this position to this position like this. Okay, from this to this position. So basically what I am doing, I am changing, I am displacing this chalk from its original position. Its original position is this one, now I am displacing it to this point. So basically I am applying force to displace it from its original position. That is, if I am applying force, definitely there is some work is done. Okay, now if the work is done, that work cannot be destroyed, it cannot get destroyed. Okay, what will happen to this work? This work that I did to move this chalk from this position to this position, it will get stored in the form of energy. Okay, that work I have done on this chalk, it will get stored in the form of energy inside this chalk. but it's not moving. It's not moving, okay, it's stationary. I am holding it here, now I am holding it here. So it's not moving, means initially it was at rest, finally when I moved it to this point, it is again at rest, but again I did the work. So that work is stored in the form of energy, but what kind of energy? This energy cannot be called as kinetic energy because it is stationary. If it would be like this, it is moving continuously, I would have said yes, this is kinetic energy. But right now it is stationary at this position. It means it possesses some different form of energy, and that different form of energy is called as potential energy. So potential energy is something which is created or which is stored in the body due to the change in its position. If the position of an object or position of a body is changed, it can possess potential energy. Okay, and let's take another example. For example, a spring. Okay, if you wound the spring continuously using a key, okay, for example in your watch, okay, in your clock, so or in a toy, if you continuously wound the spring using a key, what will happen? The shape of that spring will going to change. And if you hold it in that position, is it going to move? No. If you are holding it continuously, it will not be able to move. Okay. So what I will say, that when you wound the spring using a key, the energy, that the work that you are doing for this particular task will get stored inside that spring in the form of potential energy. Okay, in the form of potential energy. Or let's take another example. For example, at your home, you have a tank in your home. Okay, now to lift the water to the terrace, okay, to some height, you have to use a motor. Okay, you have to use an electric motor. That electric motor, that electric pump, what does it do? It takes the water from the ground and pumps it to the top. Okay, at the tank which is kept at the top of your home. So what is happening? That water from the ground is getting lifted due to that pump, and it's carried to the tank which is at the top. So in this process, the energy is used. What kind of energy? This energy is given by the pump. That is the electrical energy. Due to electricity, that pump is running, okay, and that pump is doing some work on water. Okay, that pump is doing some work on water. It is trying to move that water from the ground to the top. So in this process, what is happening? The pump is continuously applying energy, it is continuously doing some work. So where does this work will go? This work will going to store inside the water, okay, in the form of potential energy. Now when you can see, when the water comes from the top, okay, it will come with a great speed. Okay, now if you lift the water at more height, then what will happen? It will again come with the more speed. So you have seen in the hydroelectric power plant, where water is used to create electricity, what happens? The water is kept at the top of a height, okay, at some particular height, and it's thrown from there. So what will happen? The turbine kept at the bottom, it will start rotating. Okay, the turbine will going to rotate. So it means the picture would be something like this. For example, this is the height, okay, this is the height, and this is the water tank. This is the water, this is a tower, and here there would be a turbine kept like this. There would be a turbine like this, and what will happen? If you throw the water from the top, it will fall on the turbine and it will rotate. Okay, it will force the turbine to rotate from at its position. So it will start rotating like this. So what does it do? When you rotate this turbine, it will be connected to a generator and it will create electricity, and that's a different concept. So the basic thing here we need to know is that water which is kept at the top has the ability, has the energy to move this turbine. So why it is possible for this water to move this turbine? From where did it get the energy or the ability to move this turbine? It's because this water is kept at height. Now how this is kept at height? We are pumping this water from the ground and keeping this water at the height. So we are doing some work. We are doing some work to move this water to the height, and in that process, that work done by us to move the water to that height is stored in the form of potential energy. And that energy, when you throw this, when this water falls down from this height, what will happen? This potential energy will get converted into kinetic energy. Why? Because here the water is just stored. But if this water starts falling, what will happen? The water will be in motion, and due to this motion, it will possess kinetic energy. Okay, so this is a basic process which is used in the hydroelectric power plant, where the electricity is generated using water. Okay, so we will say that what is potential energy? Potential energy is the energy of a body due to its position or configuration. Now, what is configuration? We know that position, you can easily understand this term position, but what about configuration? Configuration is, consider a spring. Okay, you using a key, you wound the spring. So what will happen? The shape of the spring will get changed. We will say that the configuration of the spring is getting changed. So that is the configuration. If you wound it more, what will happen? It will rotate in the reverse direction with more speed, okay, with more energy. So this is how we will say that the configuration of the spring. So here we will say that potential energy is something which is due to the configuration or the position. Now, how to realize this position? For example, consider this chalk. I am holding it like this. Okay, this is a chalk. I am holding it like this. Now, what will happen? When I hold it like this, it has some potential energy. Now, when I drop it, what will happen? It will fall down with some speed. Okay. Now, if I move this chalk from this position to, let's say, this position, what basically I am doing? I am applying force to move this chalk from this to this position like this. So it means I am displacing this chalk from its original position by applying a force. And if the force is applied and displacement is seen, we will say there is work done. Now when the work is done, where this work will go? If I move this chalk from this height to this height, I will say its potential energy will going to increase. Okay, its potential energy will going to increase. Now what happens to this increase in potential energy? When you drop this chalk from this height, it will fall with a greater speed. Okay, you can imagine this, you can very clearly realize this. If I drop it from here, it will fall with a small speed. If I drop it from here, it will fall with the more speed. If I drop it from here, it will again fall with greater speed. So it means as I lift this chalk upwards, what will happen? Its potential energy will going to increase, and when I drop this chalk from more height, what will happen? The kinetic energy will also increase. That is, the stored potential energy will get converted to kinetic energy. Okay. So using this concept, what we will do? We will define the expression for potential energy of a body. We will try to determine the expression for the potential energy of body. Okay. So for example, consider this is a surface. Okay, this is a surface, and a body is kept here, or the ground, and a body of, let's say, mass m is kept on this ground. Okay. Now this body of mass m is kept on this ground. So let's assume that when the chalk is on the ground, or let's say when any object is on the ground, we will say its potential energy is 0. It do not have any potential energy, because if you lift it, or we can say if you drop it, what will happen? It will not get dropped, it will not move, because it is already on the surface. Okay. For example, this chalk, if I drop it, it will fall on the surface. Now will it going to fall inside the surface? No. it will only fall on the surface, and I will say, let's assume that when the object is on the surface, its potential energy is 0. Okay, so we will take an assumption that when an object is on surface of earth, its potential energy will be equals to 0. So here I will say the potential energy of the object is 0. Now what will happen if I lift this block to a height h with a constant velocity? Okay, means I will not apply too much force, I will apply only that much force which helps to cancel the gravitational force. That is, I move this block with a constant velocity to some point. Okay, now to move this block to some point with a constant velocity, the force that I have to apply will only be equal to the gravitational force. Okay, so what I will do is I will apply a force F on this block to move it from this position to, let's say, this position, which is, that is a mass m block, to this position which is at a height of h. To this height h I have to lift this block like this, okay, by applying a force F. Now you can see that if I am applying a force F on this block, I am doing some work because I lifted this block by this height. So I displaced this block from this position using this force F. So here I will say the work done on the block will be equals to, work done on the block would be equals to force into displacement, that is F into h. Now what is force? Since I want to move this block with a constant velocity, I do not want this block to accelerate, I do not want some special force on this block, I will apply only that much force which can cancel the effect of gravitational force. Okay, so I will say the force that I am going to apply is equals to the gravitational force. Now how much force the gravity is applying on this block? You can see this block is of mass m and the gravitational acceleration is g, okay, small g. So the gravitational force will be equals to mass into gravitational acceleration, that is F will be equals to m into g. So from here I will say that work done will be equals to mass into g into h. Okay, that is mass into g into h. So this much work I have to do. Now what will happen to this work? Since I am moving this block from this height to this height and it is stationary at this position, it is not moving, I kept on holding this block like this. What will happen? I will say that the work that I did on this block will get stored inside the block in the form of potential energy. So we will say when the block is lifted to a height h, the work done on the block is stored in the form of potential energy. Okay, so how much work I have to do? I have to do m into g into h work. So the potential energy of the block at this position, potential energy of block would be equals to work done to lift the block. And how much work is done? M into g into h. So we will say potential energy is equals to m into g into h. Okay, that is mass into gravitation, into gravitational acceleration into height or the displacement. Okay, remember the most important point is this h represents displacement. It is not the distance. Okay, it is not the distance. It means if I lift the block directly from this point to this point, I have to do mgh work. Now if I lift the block like this, if I take the block here and then move here, then again here, and then again, and if I keep the block here, again I can see the displacement of the block is only this h height. It do not matter whether I am taking the block like this and then moving it like this and coming to this position. It do not matter. Okay, the work done that I have to do will remain m into g into h, because work done is force into displacement. So this is the initial position, this is the final position. You just need to take into account these two positions. It do not matter from where you are coming and how much distance you have traveled. Okay, so it means this is a chalk. If I move this chalk from this position to this position, the work done will be some finite value. And if I move this chalk to the same position but moving it like this, if I move it like this and from some random path I come to this position, I will say the work done will not going to change because it is the displacement. So we will say it do not matter how much distance is travelled. Okay, it do not matter how much distance is travelled because this h represents the displacement. You just need to take into account the displacement of the block from its initial position. Okay, so this is all about the potential energy. You need not to go in much detail. There are some more definitions, that is, for potential energy represents the work done by or work done against the gravity and all these kind of definitions. It's not required for your course. Okay, so this is, you can note about the potential energy. Just remember this formula and you will get mostly the questions related to this formula. Okay, so this completes the potential energy. Please note down this.